Hello, everybody. You're all very welcome to this event. I think most people are here by now. My name is Owen Gill, and I'm from Waterford Institute of Technology, and I'll be hosting this event today. So this is a festival called Toys4Engineers that has been running for several years in Waterford, and it's all about supporting the STEM regions, the STEM industries in the regions. And this is a special event today to highlight the careers available and the opportunities available in the region through STEM. The event is coordinated by Waterford Chamber of Commerce in association with Waterford Institute of Technology and with Engineering the Southeast Cluster, with support from Energia and Red Hat. And this event today is being sponsored by Red Hat, and we're delighted to have James, who is the Director of Red Hat in Waterford, here with us, and he'll be talking to you later on and introducing you to some of his team. We also will have Stephen Rooney. Actually, I need to share my screen to share the program with you. So the we have in a few minutes we'll have the opening address by Grace O'Sullivan. I will talk to you about engineering, and then we will have James and the Red Hat team, and then finally we'll have Stephen Rooney from Engineering the Southeast talking about apprenticeship options. So this program has been put together to give you a very wide overview of opportunities that are available to you all. So some of you might be interested already in engineering and the wider STEM area. Some of you may not. That's fine, but we think it's good for you, whatever your interest, to find out about the world of STEM, because our lives are so much dependent on science, technology, and engineering. And it's good, even if you decide to choose a different route, and we encourage you to follow your dreams and to do something that you like. But whatever you do, it's good to understand how the world of science, technology, engineering, and maths works. So everyone should find something of interest here today. So just to see who is here before we start, these are hopefully you're all here with us. Art School Lamar and Tremor, Lorette from Kilkenny, Kilkenny City Vocational School, St. Angela's, the Ursuline here in Waterford, Tyndall College in Carlow, St. Declan's in Kilmacthomas, the presentation in Kilkenny, Gael Colosh the Fort Loriga, Tá Fáilte Rove Galair, and Newtown Secondary School in Waterford as well. So if there's anyone else here who'd like to identify themselves, or if you have any comments or questions throughout the session, please pop them in the Q&A area, and we'll get to them today. We really would encourage you to ask questions today. That's what we're here for, and there's a very experienced and capable team here to answer them. So I think Dean has our opening address from Grace O'Sullivan. Grace is the member of the European Parliament. She's from Tremor in Waterford, and she's been a lifelong activist for sustainability. And that's something that's very close and central to everything we do now. So we're delighted to have Grace O'Sullivan to talk to you today.
Hi, I'm Grace O'Sullivan, a Green MEP and a lifelong learner. I just wanted to say enjoy this opportunity today as you explore options around careers in STEM areas of science, technology, engineering and maths. And of course, we're all familiar with the acronym STEM, but I'm going to throw in another acronym that I'm particularly fond of, and that's STEAM. So STEAM stands for science, technology, engineering arts and maths. It takes STEM a step further. And a quote from Seamus Devlin, one of the co-founders of STEAM Education Limited. He explains it well. Science, he says, is the means by which we seek to understand our universe, and maths is the language in which science is described. Engineering and technology capture that understanding and its language to improve our lives, whilst the arts provide the medium through which such progress is woven into civilization. So as you consider some of your options presented to you today, remember that learning can be a lifelong adventure, and in the words of the great educator in our locality, founder of the XLC project, Nuala Jackson, education is no burden. Carry it lightly, enjoy the fun of learning and a possible career or careers in these exciting areas. I wish you every success in the future.
Well, thank you very much, Grace. Are we seeing my screen again? Do I have to share it again?
Might need to share.
Yeah. Okay. Okay, we're back. So I'm going to talk a bit about engineering itself and try and answer the question, what is engineering? My name is Owen Gill. I'm a chartered engineer and a lecturer in engineering in Waterford Institute of Technology. I run a centre called CalMast, and that's a STEM engagement centre. And we're supported by lots of local industry and Science Foundation Ireland and other groups. We work with the local authorities, and we work with groups like Red Hat and the Engineering Southeast cluster as well. So our interest is in telling people about STEM and telling about how it impacts on our lives and how what opportunities there are for everyone in STEM. So just to say that sustainability must be at the heart of everything we do. So what we're doing is in STEM, we're rooted in society. We have to serve society. And one of the core concerns at the moment is sustainability. And that has to be at the heart of everything we do. And we'll just mention that later on. So what we're interested in showing people is that going from school in the Southeast, you can go to college. There's opportunities in college here in the Southeast, both in ourselves at Waterford Institute of Technology and also at in Carlow. But you can come to college in the Southeast, get a STEM qualification and go into industry in the Southeast. There has been a huge amount of industrial development and new jobs and new exciting high-tech firms coming into the Southeast. So there's opportunities there for you. Of course, I'm not saying that you all have to stay in the Southeast. Many of you will want to spread your wings and go to explore other countries and places. But remember, you can always come back. There'll always be a job for you back here as well. At the moment, almost 94% of engineering employers are concerned about a shortage of experienced engineers. So the employment opportunities are very, very strong and very strong in the Southeast among employers. Now, going to just ask, what is STEM and what is engineering, which is a question that may be on your minds. It should be on your minds if you're coming to this event, although some of you may be very familiar and may be able to give a better answer than I can. So STEM, as Grace mentioned, is science, technology, engineering, and maths. And this is an acronym. This is from the first letters of these words put together, and it gives us STEM. Now, there's a reason to put them together, and that is because they're all interconnected. As Grace said, science is about exploring the world, but scientists need to use maths because maths describes the world. Science and maths are used by engineers to produce technology. So they're all interconnected. And as was mentioned, we often talk about science, technology, engineering, art, and mathematics. And that's also helpful in that it shows us that STEM is a creative area. Engineering in particular is about creating. It's about having innovative and creative solutions to problems. And obviously technology is very creative as well. And indeed science and maths. So you might be used to in school science and seen as more of a collection of facts and maths as tools to do things. But in fact, science is all about exploration. In fact, scientists are more working with the unknown than known facts and creating new knowledge. So creativity is at the heart of this. So now engineering, of course, is the E in STEM. And what is engineering? Now we can reach to, if we Google it, we will get a definition somewhat like this. Engineering is using natural resources, materials, and energy to design and make products or processes for the benefit of society. Now, that's a great definition, but it really doesn't tell us very much. It could be talking about a baker or a dressmaker or lots of different people. So I think we need to look at where engineering comes from to understand it a little more. So the word engineer doesn't come from the word engine. It's not somebody who works with engines necessarily. They both come from the Latin word ingenium, which is the root of our other word that we use is ingenuity. So an engineer is somebody who relies on ingenuity. Now, we look at where maybe engineers come from, or where, let's look at where bridges come from. So imagine a world without engineering back in prehistoric times, and maybe you're coming out of your cave, your Stone Age, and you want to cross the river, and now you see a tree has fallen across the river and you don't have to get your feet wet anymore. So you start walking across on the tree. And then maybe you might get the bright idea of knocking over a tree beside a river, and you've made the first bridge. Okay, so you're using natural resources and coming up with something that's useful as a solution. And then maybe it could be thousands of years later, it evolved more and more, and somebody is now at the stage where they can tie logs together and make a more sophisticated wooden bridge. And we move on to using stone. And now stone was used a lot longer than this, long time before this. This is 1205, and this is in the Curramore estate in Portlaw, and they claim that's Ireland's oldest bridge. It was built for the arrival of King John to Ireland. You might remember him as the Prince John from the Robin Hood stories. So stone then was used, and very, very good building material, very, very strong. And we could you can't do very long arches with it, but you can put lots of arches together and get a very long span. So this is an example of how the design is evolving, how people are pushing the boundaries, and they've taken they've learned what has gone before, and they're looking to see, oh, how can I make this better, make it go higher or further? And here is the railway viaduct in Kilmacthomas, and many of you will be familiar with the pictures of the Roman aqueducts that were built over maybe 2,000 years before this viaduct. But that's a very spectacular one, and the greenway goes over it, so you can get a great view of it if you go along the greenway. So they're stone bridges. So there's a limit. There's a limit to what stone, how much we can do with stone. And then in the late 1700s, people along the River Severn in this Colebrook Dale, there was ironworks, and they thought to themselves, maybe we could actually build a bridge from iron. This is the world's first iron bridge. And it's actually made as if it was a wooden bridge, but using pieces of wrought iron for it instead, or cast iron for it instead. And so this showed people that there was a new material possible, and that gave new possibilities. So iron was a much stronger, more versatile material to build bridges. But there's a limit to how much a bridge like that can span as well. And that was found, there was found to be a better way to get long spans. And this is the first modern suspension bridge in the world. And this is, if you ever go across to Britain, to Wales, if you go across to Holyhead and drive down out of Holyhead, you'll cross a new bridge beside this one, but you can see this bridge. It's still standing, still working, built in 1826. So here you can see this is far, far more sophisticated and complex to this one, and certainly to this one. So you need a lot more knowledge in building a bridge like this. So at the time, the understanding of science was improving a great deal. We understood more about how the materials work, and we could understand the forces working in those materials. So we're starting to bring mathematics and science into our engineering. So going from just learning from what other people did and what worked before, we started to use maths and science to understand, or to be able to figure out what's going to happen before we actually build this, because we can't just build something of this expense and size and just to test it out. We have to be reasonably confident what's going to happen before we start. So engineering is becoming more sophisticated, relying on using maths to understand how things will work. And so that suspension bridge then, we have, here's almost 200 years later, we're at this level. And this is Ireland's longest bridge. If you go from Waterford to Wexford, you can pass over this bridge. It saves going through New Ross, and it saves the people of New Ross having terrible traffic congestion, which they used to suffer from. So this is almost a kilometre long and very, very high over the river Barrow there. And here it is from the approach from the other side. So this is a very sophisticated construction, and this would have been designed on computers, and those computers are using a lot of mathematical descriptions of how these materials work with each other. And I should say, I should have mentioned that we have reinforced concrete in this. So concrete supplanted stone for building, and is also far more versatile. So steel and concrete is how a lot of major structures are built today. So this bridge would have been designed by computer, and the designers would have been able to check and see exactly how it would behave when a lot of traffic goes over it, if it got covered in snow, if there was a hurricane blowing from any direction. All of these things can be modeled because the designers make a mathematical description of it, and they input that, they program that into a computer, and they can run that model and see exactly how this will behave. So we need to be we're able to tell the future, because this, of course, costs huge amounts of money. There's huge safety issues involved. We need to know exactly how it's going to work before a sod is turned on the job. So now, where are we now? Where do things go? just like 200 years ago or 250 years ago with the first iron bridge, what we've had just recently is this is the first 3D printed bridge in the world. And that is actually printed with stainless steel. So many of you might be familiar with 3D printing using plastic or polymers, and this one is steel, and it's quite ornate. It's like a piece of sculpture, and this took, I think, 6 months with 4 robots depositing stainless steel layers on top of each other. So the question is, that's a very small span compared to the Rose Fitzgerald Kennedy Bridge. But the question is, what is this the start of? So when in 1779, when they built the first iron bridge, they couldn't have dreamed that of bridges that were spanning like the Empire, like the Golden Gate Bridge in San Francisco. They couldn't have dreamt of those huge bridges. And now I'd ask you to just wonder where this technology will bring us. So we might be at the start of a very exciting new period that in structures. So that's the area of buildings, constructing, and we're going to now look at just something slightly different. Actually, our last picture had water in it, and this picture had water in it as well. So we're going back in time again, and this is this time to the medieval Islamic world, and we're going to look at something about water supply. Now, this diagram, you will see we have a poor cow working away here, working away, turning this axle, and this turns these gears, and this gear turns around this conveyor, this bucket and chain system, and these vessels dip in the water, come up full, and they spill out here, and this then flows off somewhere where it's needed, either as a water supply or to water crops. Now, there's a secondary mechanism here, and this is where the water current here is turning this water wheel, and this water wheel is also turning this cog here, and that also powers the machine. So I suppose this was probably in the imagination of the artist, but devices like this were used commonly. The Islamic world was very sophisticated in science and technology and mathematics in the Middle Ages, and they also obviously had a great need to move water from one place to another and irrigate crops. And of course, that's a very important concern. It's not really something we think about in Ireland because our crops are irrigated by the rain very successfully. And in many parts of the world, water is a major issue. And the provision of water, both for growing crops and for drinking water, is really, really important. And it's something that engineers are involved with. So this was used animal power, water power, and we also had wind power at that time. We had windmills, generally sometimes pumping water and generally grinding flour. So they were the sort of mechanisms that were being used in the Middle Ages. Then with the development of steam engines, this steam engine would have been used as a pump. This is a model of a very early steam engine, and this would have been used as a pump to pump water out of mines. That was the first big use of steam engines, to pump water out of coal mines. And then this technology developed, and we had very big steam engines. This one here is in the Science Museum in London, worth a visit if you're in London. And this device could be used to haul lifts up and down, haul workers and equipment up and down into mines. And it could be used the power could be used for other things in factories, to move machinery in factories. And of course, it wasn't long before somebody got the idea of connecting a steam engine to a set of wheels and make a self-driving locomotive. Now, this is a much later version of a steam engine, a steam train. And this locomotive, these would have been common all over Ireland and the rest of the world up until, I suppose, around the middle of the last century. And one of the main problems that we think about this technology now is behind that engine is a big wagon full of coal, which was used to keep it going. So obviously, they were very polluting, and they're very damaging to the environment, producing a lot of carbon. We wouldn't have them now. So we need to look for new technologies, and as new pressures come along, as new demands come along, engineers innovate and come up with new solutions. And so I'm going to jump, I suppose, a century through the development of cars to the modern offering. And this is, of course, the top of the range with electric cars, the Tesla. And this is an example of where we are today. But this is a progression from original pumps. But when we got to steam engines, we needed to be more sophisticated. We needed to know more about the science and the mathematics. And again, just like with bridge building, the mathematics and science started informing how engineers work. So now, again, these are all designed on computer. The manufacturers know pretty well how they're going to operate before they're built. Of course, they still have to be built and tested and improved. But this is where we are now with I suppose, top of the range electric vehicles. So again, we see engineering developed and became more and more sophisticated. And now this has happened with a lot of new disciplines. So we first described structural engineering, which would be part of the civil engineering family. And then with machinery, as machinery became more advanced, the area of mechanical engineering grew up. The late 19th century, electricity started being used for lighting and for motors and things, and electrical engineering grew up. In the middle of the 20th century, it was determined that electricity could carry signals and carry information. So in the middle of the 20th century, electronic engineering grew up. So electronic engineering is concerned with electricity, where electricity is used, electricity and magnetism are used to transmit information, communicate information, store information, and process information. So that's the world of electronic engineering. And as that developed more and more, the idea of writing programs to process this information and to move this information around became more and more important, and software engineering developed. So software engineering is concerned with developing programs and apps and packages that process information.
James, we might go straight to you then, if that's all
Yeah,
right.
no problem.
And we'll bring Owen back later on, because there are some actually really interesting questions here for him. So we'll definitely put those to Owen at the end. But for now, we're delighted to be joined by James Mernon of Red Hat. Red Hat have kindly sponsored our event today, and we're so thrilled to be working with them again. We've done a number of projects with Red Hat in the past, so we have quite close links with the guys. And James, we'll leave it over to you. I think it's going to be very interesting, and we're dying to hear what all about Red Hat and what you guys are doing.
That's great. Linda, thanks very much. And you've got dinner. That's my homage to the Gaelcha Uiste, Fort Lauriga. So we're going to talk about full steam ahead, and I was delighted to see Grace O'Sullivan spend some time talking about STEAM versus STEM, and I'll touch on that again in a couple of minutes. So quick agenda, we've got about 30 minutes to talk to you today, and hopefully that will fly by, and I'm joined by some of my colleagues who I'll introduce later as well. So we're going to talk about the advent of STEM to STEAM. I'm going to talk a little bit about the different types of roles that exist in the software industry. And then we'll have a mini panel discussion where you'll get to hear from some of our more recent graduates at Red Hat in Waterford, hearing a little bit about their journey to get to where they are. Is it what they expected it to be? How did it work out for them? And then we'll finish off with some top tips that we discussed in the recent couple of days that we'd like to share with you. So quickly, I won't spend a lot of time talking about Red Hat, but just for those of you who don't know what it is, it's a global software company. They've got about 40 different countries. We've got a presence in about 100 different locations. And they're quite well known for their own operating system called Linux, but they do an awful lot more than that as well. The type of software that Red Hat creates is more for large industry and other large companies. So that a lot of the banks run our software, and airlines and car companies and so on. And the interesting thing about Red Hat as well, they actually give the software away for free using a development model called open source, which is a bit weird for some people in terms of how can you make billions of dollars in revenue from selling free software. That's another talk in itself. And the other thing is Red Hat is actually now owned by IBM, one of the world's longest running computer companies, dating back over 100 years. And IBM acquired Red Hat in 2019 for the princely sum of $34 billion, which was a huge amount. And it's the biggest software acquisition in the history of all time. So we're quite proud of that. So we heard earlier about STEM, which is science, technology, engineering, and maths. I don't think we need to spend too much time on that, but I did want to spend a little bit of time talking about STEAM. So Grace O'Sullivan gave a great introduction. I really liked the way that she describes the way that the arts is the way in which it's interwoven with all of the other disciplines here. But what I wanted to give a shout out today is that in terms of the arts, if you're studying music, anything creative, art itself, technical drawing, any of those things with a creative nature, don't let anybody tell you that this is not a valuable asset to you in the software industry or in any industry for that matter. We're very passionate about that, and I'm personally quite passionate about it too, because that level of creativity and the way that you think and the way that you approach a problem is hugely important in order for you to apply all of the other disciplines that you may or may not be passionate about. It doesn't mean that you have to love all of the other disciplines itself. It just means that if you are leaning a little bit more on the artistic side, there's absolutely jobs for you in the software industry and in the IT industry as well. And don't be afraid to pursue a career there based on that. Even if you feel that some of the others don't quite float your boat, that's perfectly fine. I'll talk a little bit more about that in a moment as to why that might be the case. So software engineering as a discipline, we talked earlier, it is an engineering discipline. We are engineers, we all have degrees and master's qualifications. There are some people who don't have any qualifications at all, and you'll find that in most industries too. However, what I wanted to talk about here is having a role in the software industry doesn't mean that you're going to be a computer programmer and that's all that you do all day. This here is a word cloud that we created based on the job titles of some of the staff based at Red Hat in Waterford. And what you see here is a whole plethora of different type of periphery roles, all still centered around the IT industry and software in general. But we have people employed at Red Hat that are not coding all day. A couple that I draw attention to, technical writing is a very strong presence in the Waterford office where people are writing user documentation and in very creative ways that helps people to use the software that we design a little bit more effectively. We also have a very interesting take on quality. So many companies have quality assurance departments, which are arguably checklists and test plans for making sure that the software does what it's designed to do. At Red Hat, we actually have a team called quality engineering. They're still engineers, but their focus is on quality. So they do a lot of automating the testing of the software. It's a great career. It's very interesting. You're still doing a lot of problem solving. We also have engineers in product security, forensics, information security, very strong there. They're still engineers. We have engineers working in an area called site reliability engineering. It's a fancy word for the teams that run all of the different servers and infrastructure that powers all of the systems that we use. So the next time you use an Instagram or any app on your phone, think about what's happening out there in the cloud that's making this application work, that I can share all my photos with my friends and things. There's a world of infrastructure out there based in the cloud, and somebody's running that very efficiently. And we have a lot of people, and we're going to be meeting one of them shortly, that are in that career. So there's a lot of different kind of roles, all centered on the IT industry, where you could apply any one of the STEAM acronyms, including the arts. So again, I would encourage you to consider it as a career, and you'll hear from our colleagues in a moment about that. It's certainly something you should consider, and you don't have to be too focused on actually coding every day. And if you do, that's great too. One of the things we talk about a lot in interviews is teamwork and problem solving. So most of the engineers that we work with, they're great problem solvers. And at the end of the day, that's what we actually hire them to do. All the world's companies and every person in the world has problems that they need to solve every day of the week. So if you like a good puzzle and you're intrigued by just problem solving in general, maybe a career in the IT and the software industry is for you after all. And you're definitely going to be working in teams, and none more so than under the current situation where most people are working remotely through COVID, that you could be working with teams that are either physically in the same location as you, or you could be working with teams right across the world, and there's lots and lots of travel opportunities around that as well. So I'm going to hand over to Leanne now, who's one of our project coordinators at Red Hat. And Leanne's journey as well. She's doing one of those non-core software engineering roles. She helps work with our other teams to make them work more effectively. And Leanne is going to take you through some discussions with our other colleagues to talk about their journeys into the IT and the software industry. Over to you, Leanne.
Thanks for the introduction, James. I hope you can hear me okay.
Yep.
Okay, so we have 5 lovely panelists who have agreed to share a little bit of their journey and their story with us today, and I'm going to ask some questions to them. So I'm going to jump straight into it. I'm going to ask Enda the first question. So Enda, you were undecided about what you wanted to do after school and took a year out to give yourself time to make up your mind. Can you tell us a bit about that, and were your parents okay with that decision?
Yeah, sure. So I think like a lot of people, when I was in my leaving cert year or even 5th year, I just had no idea what I wanted to do. It's kind of very young to know what you want to do for the rest of your life. So, and actually the first choice I had down was journalism, because I was quite good at English. But still, like there was a lot of pressure at the time to feel like you need to move on to university straight out of school. And when the CEO points came out, I had my first choice was journalism, and I didn't get that. So I was a bit in a bit of limbo as to what to do. So like actually you mentioned my parents, what their idea that was, they actually suggested it to just take a year out. I felt like I needed to go to university straight away because a lot of my friends were going as well, and I felt like I'd be left behind. So I took their advice and I did that really. And I did a PLC. A PLC in beside IT Sligo, where the college was actually, and I did it in computers because I knew I liked computers, but I never really had exposure to software at the time. So I was a bit hesitant of doing it because you do hear a lot about it's all about maths, and I wasn't that strong at maths. I did ordinary level maths, so I did a PLC course there for 1 year. I ended up loving it, and just like I really knew it was for me, and it was a great decision. So following that, I applied to IT Sligo, which I went into and did 4 years there, and I just loved every minute of it. And like, yeah, it was a great decision. So the second part of your question about my parents, yeah, they encouraged me to do that. They didn't pressure me to do it, but it all worked out really well, you know.
That's great, Enda. Interesting story too. I know some parents wouldn't always suggest that, but it's great you're on board.
Yeah, and like my brother and sister did the same thing after me, and they're both in science and engineering as well. So like it works.
It works, exactly. Thanks very much. Okay, so I'll direct my next question to Rachel. So Rachel, you landed in your chosen college course in a non-traditional way, and the course you first started in is not the course you graduated from. Can you tell us a bit more about that and what made you change course?
Yes, of course. Thank you, Jan. I originally started in UCC doing an arts degree. So I was up there and I decided I'm not really the biggest fan of what I'm learning and what I'm doing. So I made it the kind of nerve-wracking decision to drop out and take a year out. So I made that decision and it was the best decision I ever made. So I come back down to Waterford, and I thought initially that I would have to take a whole year out because college already started, so there was no way of going back in. So I decided to have a look at WIT anyway and see what courses were there so I could have the whole year to think about what I wanted to do. So I was having a look on the WIT website and I saw that there was this available places option, and I'd never heard of available places before. So I looked into it and I found out that it's courses in college or universities that aren't full up yet and that you can still apply to even though that the semester has already started. So I saw this course called the Internet of Things that sounded like this totally made up course that I'd never heard anything about. And I actually found out that it was the first year running. So we were the guinea pigs for that course. And it was a computer course. I was a little bit apprehensive at the start to go into it because, like Enda, I had ordinary level maths. It wasn't my strongest suit, but I decided anyway, sure, look what's going to happen anyway. We'll go into it and see how we go. The maths actually was not in any way as hard as I thought it would be. The modules were very well explained and I passed all of them. So I'm glad that I didn't let maths hold me back from doing this course. So I end up graduating in the Internet of Things, and I then start working in Red Hat straight out of college. I caught the eye of Red Hat from a project I did in fourth year, so that got me under their radar. So then I started in straight out of college in September in Red Hat, and I started off as a software engineer. So I am currently now a software engineer specializing in site reliability and monitoring. This is not exactly what the IoT part of is. I had the foundations of software engineering from the IoT, but I learned everything else about monitoring and site reliability on the job. So that was great that I could get the information I used from college, but still be able to change into a part of software engineering that I didn't even know existed. I thought software engineering was completely just coding based and they had no kind of specialities that you could go into. So in the end, I wasn't the most traditional way of getting into college and then getting into this industry, but I'm so glad I made that jump for dropping out of UCC and moving into WIT. It was the best decision I ever made. So yeah, that's kind of my story.
Great story. Thanks for sharing. Okay, so we'll move on then to Piyo. So you came into Red Hat as a graduate consultant and have since moved to a very different role. Can you touch on the grad program and what it involved? And did you ever imagine yourself in a tech support role?
Yeah, sure, Leon, thanks. So I was a graduated and I wasn't had any previous experience. So I started working as a graduate consultant in Red Hat. And I wasn't really sure like how the work goes and how the roles are, different roles, different products they have. And in graduate programs, especially, they will help you to find your own career path. They will give you some more options. So what we do, what role makes sense and what you like, they will help you to make to know about your choices. And also they will give you some trainings with the soft skills as well. So you'll be they'll be helping you to convert yourself from student to the professional. So that will help a lot in the graduate program. So you may have heard about the graduate program many times. So that is the one I'm talking about. So which really helps you to convert yourself from student to professional, as well as I joined as a graduate consultant. So I was learning about the consultant, but I wasn't aware about some challenges which were coming in front of me. But yeah, just a year after I joined, I got an opportunity to be a technical support engineer, which I never thought of. But I thought I'm not going to survive here. But there is no pressure at all. Like I got some time to get prepared for the role, and then I got some training as well, and I really get it on with the team, and I was really good at that. So I didn't even think about the support thing as I was a consultant, but once I changed the role, I've been into the support team, and now I'm learning a lot. Like I'm getting opportunities to learn every day. I'm learning something. So this is not just like one role, but even if you change the role, or if you even get any challenges in your role, that you'll be prepared for that. And that's what the graduate role especially helps you to make yourself and to choose your career path. Yeah, that's my story.
Thanks so much. It's great to hear of people who've transitioned to roles that they never even considered and the impact it's had on you. Okay, so Ellen, we'll move on to you. I have a question for you as well. You're the only panelist who comes from a business background. Similar to Rachel, you also switched courses, and I know you say that it was the best decision you ever made. Can you tell us the course that you originally started in and the course that you changed to, and why you think it was the best thing you could have done?
Yeah, absolutely. So I originally started studying arts at Maynooth University, and I changed to studying Bachelor's of Business Honours in Management in WIT. So not only did I change courses, but I actually changed schools as well. So I had chosen business and Spanish as my art subjects initially at university. So my course content didn't change too drastically, but it was the delivery of the information that was so different between IT and then the university. Both were brilliant courses, but I think changing back to WIT was the best thing I could have done for two reasons. So firstly, the business management course was just what I really wanted to do. And secondly, it was the practical environment of an IT that I personally thrived in and I thought was the most like working in an actual organization. And sometimes ITs can get a really bad reputation or be put down as being less than universities. But in my opinion, I think they have as much to give, if not more. And the business course at WIT was also very current and focused on innovation, which is what led me to where I am today. I don't doubt that if I had continued with arts, that it would have really stood to me as well. But it was the change back to the business course that really helped me achieve my goals. And it was the exposure to industry that I received when I was at WIT that really led me to work in technology. I would never have thought that there was a place for a business manager with no tech background to work in IT until I actually went and spoke to somebody from that industry. And to further James's introduction, comparing STEM to STEAM, I was really artsy at school and really creative growing up. So my skills were singing, painting, performing. I never really liked maths or accounting or any of those courses that I found to be very hard. And it's the soft skills that I learned from being creative that I bring to work every day to communicate with my teams, to collaborate and solve problems with them. Technology, funnily enough, has actually been the most creative environment I've ever worked in. So if you can take anything away from this, it's to think outside the box for your skills and your strengths, and think openly about industries that might suit you, even if it might typically seem so from the outside. I've since gone back to do my master's at Maynooth Universities because that's where they offered the course that I wanted to do. So it's really important when you're choosing, there's no right or wrong between IT or university, but so long as you're choosing the course and the level that works for you, then you're on the right track.
Thanks so much, Ellen. Some great advice in there. Okay, so last but not least, we have Ben. I also have a question for you. So Ben, you took a very different path to college as a result of poor Leaving Cert results. Can you briefly explain the path that you took to get to where you are? And would you do anything differently if you could go back in time?
Yeah, so my journey is a bit more of a cautionary tale, to be honest. I did absolutely nothing for the Leaving Cert and I ended up getting 145 points. I then spent the next 7 years or so going through computing PLC courses and just dead-end jobs, like basically washing dishes in a hotel, working in a meat factory, working in a tomato farm. And one thing you really need to know about factory jobs is they're really boring, and it's basically the same as school. You're told not to talk because it affects productivity. You're told to do the same thing all day. You have no autonomy, and you just have to do what you're told or get sent to the office. So I decided I was going to go back to WIT. I'd always had a passion for computers. So I went back as a mature student and decided it was now or never to get my degree. And since then, I've been getting at least 100% grade each semester. And I managed to get an internship at Red Hat, so I can't be doing that bad. And yeah, if I could go back in time, I'd just embrace failure and start learning from it at a younger age. You really can't shy away from things because you're afraid of failing at it. It's the only way you're going to improve. And everyone here is in the perfect position to change the path you're on. If you're on a similar path to me, just put in the work now and you won't have to make the same mistakes I did.
Great story, Ben. Some good advice there too. Okay, so that's all of our panelists. I'll hand it back to you, James. I think you have some more slides you want to go through.
Sorry, just come off mute. I'm a bit speechless, to be honest. I'm humbled by the stories. I think I wanted to commend all of our panelists for having the courage to come on here today and tell their story. They're all very different stories, but I hope that they inspire you to think outside the box, as we said, and don't be afraid to make change in your life. And certainly, hopefully, you got some value from them. I had just one slide to finish off. Excuse me, I just need to move my thing out of the way there. Here we go. We asked the team earlier, what tips would you share in building on the experiences we've just heard about? One tip that was shared was find out what you don't like just as much as what you do. So a lot of people do spend a lot of time thinking about what they think they like, but take a lead from things that you discover that you don't like just as much as anything else, and that's a good outcome too. And if, for example, as a result of today's talk, you decide, I don't like the sound of a career in IT or software, well, that's great, because we've just helped you make an informed decision about what you might want to do in your life. Another hat tip to continuous assessment and projects, particularly in light of COVID, where the Leaving Cert grading system and junior cycle grading systems have been changed a little bit to take more account of past performance. Because it's a better reflection of what real life is like in industry, do pay attention to your continuous assessment and your project work now, because it will de-stress the final exam later on, but it'll also be a lot more realistic to what it's like working in industry, where you are working in a team. You're not working to deliverables that are needed, not very often working to deliverables that are needed the next day. It's more like weeks or months that are the timelines. And it's just a far more realistic representation of what industry is like. If you can get some work experience in relevant industry, please do. I do appreciate that that's very difficult under COVID. And I know that the last year's transition year students were not able to avail of any work experience. I dare say that this year's students may not be yet either. That's unfortunate. But if you can get any kind of work experience at all, dealing with people or whatnot, do certainly look to do some of that. And Ben on the call here today has a great blog, if you look him up on medium.com, telling his journey. If you want to know a little bit more details about that, there's open days available at some of the academic institutes. There's also some tech meetups that you could go and join and check out. They talk about loose technology topics and so on. And as Ben mentioned at the end, don't be afraid of failure. After all, it's a learning opportunity. Don't sweat it. Just learn from it and move on and put it to good use. And keep your options open. As all of the people here today have described the journey where they changed their mind or changed their discipline or changed their course. They're living proof that it can be done. It's not that big a deal. It may seem like it at the time, but in the fullness of time, you tend to get the outcome that you deserve and that you want, and you're all the happier for it. And the one thing that I think came across to me in listening today is that in the amount of change and failure that people have learned from, while they may not bring relevant industry experience into a role at Red Hat or anywhere else, they do bring life experience, and that's every bit as valuable to bring into any role that you're going to. So to finish off, as many of you may know, Waterford was recently voted as the best place to live in 2021. Well, based on what you've heard today, I fully believe that it's also the best place to work for your future career. So we would strongly encourage you to consider studying in the region, because I can tell you now there's lots and lots of jobs for you in the region. Thank you very much. Back to you, Linda, or if Owen is back on.
Yeah, thank you very much, James, and apologies to everybody. My internet dropped out at just a very bad time. I'm going to just talk to you a little bit about what to look for as you progress into higher education. So if I could share again. Can you see my screen?
We can, Owen, yeah.
So yeah, so this is a picture of a transition year before the pandemic on one of our Engineer Your Future activity, and that's something I'll say a little bit about in a while, because there's going to be other points of contact during the year. If you're in transition year, or if you're 5th and 6th year, you can have other points of contact with us to find out more. So if you decide you're interested in engineering and you want to find out more, well, obviously you're going to be looking at higher education courses. Now, Stephen will be talking about apprenticeships, another route to your future later on, but I'm going to talk about higher education courses. Now, the bad news is when you go to look at the CAO form, it's very confusing. You should look at this as good news in that there's a huge choice, but it is very confusing and it's hard to find exactly what everything is. So there's 127 different engineering courses listed on the CAO, and they range from everything, I think, alphabetically, agricultural and aeronautical, and right down to mechanical and manufacturing. I think that's the alphabetical spread. I'm going to just talk about Waterford Institute of Technology and what we offer here. Now, we're not saying you have to come to WIT. You may want to go elsewhere, and that's fine. There's lots of choice, and you know, the world is your oyster. You have so much opportunity and choice, but I just want to remind you this stuff here on your doorstep. So some of our speakers, the very inspiring speakers there, came through WIT, and others went elsewhere, and that's fine. One thing I will say, maybe about to echo, if you go to an Institute of Technology, you're talking generally about smaller classes where the lecturer will know you, and if you have any issues at that, they have more time to talk to you, and we've closer industry links. And there's for our 4-year courses, there's an industry internship on them. Just then to we have 3 levels, the National Qualification Standards level 6, 7, and 8. And so that can range from a 2-year certificate, 3-year ordinary degree, and a 4-year honours degree. And in terms of certificates, we have mechanical and electronic engineering certificates. So some people feel, I think, you know, 4 years, committing 4 years to college is quite daunting. I'd like to be in and out in 2 years and get a job, and or to go and get a job and come back later or train on the job. We have 3-year ordinary degrees in mechanical, manufacturing and electronics, and these equip people to become technicians in industry. On our 4 years honours degrees, we have mechanical and manufacturing, we've construction engineering, we've sustainable energy engineering, sustainable civil engineering, electronic engineering, electrical engineering, and automation engineering. And these are all different courses that you can apply to. Now, you might decide that that's very confusing. And how would I know now what exactly I want to specialize in? And that's when where the common entry is very attractive. So you can go do the common entry. Most colleges in the universities have common entry as well. So if you can't decide what exactly you want to do, you can do the common entry and then decide during your course where exactly you want to specialize. And of course, the areas are quite broad, and you're not really pigeonholed there for the rest of your life. You can move within the profession when you go into the workplace. We've other related courses. We've architecture, construction management, quantity surveying. We've a range of computing courses, software systems, the Internet of Things was mentioned earlier. We've a physics degree, and we've a pharmaceutical science degree. So there's other options apart from straight engineering. Now, I'd just like to talk about motivation. What people tell me they're often looking to is make money, or make a mark, or make a difference. It'd be nice if you can do all three, of course, but people have different motivations. Just on money, a third of the top 100 CEOs in the world have engineering degrees. This is Mary Barra, who's the CEO of General Motors. And the engineering formation is particularly attractive for management because it involves problem solving, developing analytical skills, and engineers develop structural methods of thinking that are very useful to understand complex systems, and that can be applied in lots of different areas. So once you go into engineering, it doesn't mean you're there forever. It's a very good foundation. Now, in terms of money, you can expect when you graduate to be offered around 30,000 euro, and rising up to about 90,000. That's the median. That's what most people would be on at those stages. But of course, the sky is the limit. Engineering, you could have, most people are in, a nice, well-paid, comfortable existence, but then there are other engineers who are doing quite better than the rest of us. And these three people are the richest people in the world. They've been alternating the top spot over the last 3 years. Elon Musk did physics and economics originally, but he's essentially an engineer. Jeff Bezos did engineering, and Bernard Arnault is the third richest person in the world, and he also studied engineering in France. Anyway, we don't expect everyone to want to be a billionaire, but a lot of people want to make a mark in the world. And with engineering, you can feel you've made a mark because you can see what you've done. If you were involved in the construction of the Rose Fitzgerald Kennedy Bridge, then every time you drive over it, you see, I did that. I was part of that. So engineering is good in that sense that you can see that you've made a difference. If you were involved in developing the new iPhone or a new app or a new piece of software, you can see the fruits of your labor. You can see what you have done and so you've made a mark. And then importance, making a difference, making the world a better place than how you found it. And that's really important. And we need really to focus on that now, because we made a bit of a mess of the world, and engineering is going to be core to tackling climate change. And as mentioned earlier, sustainability and the sustainability goals are central to everything we do. And things like zero hunger, food production, clean water, affordable and clean energy, these are things that engineers will have to produce. And engineers are involved in all the rest of the climate action goals, are going to be central to it. So to find out more, as I said, we're going to have different points of contact during the year where you can contact us. We have an Engineer in Your Future transition year event that'll be running in April or May. We'll have Southeast Engineers Week, that'll be running in March, and we'll have events in Carlow and Waterford and maybe in some other locations around the region. Here in Calmas, we organise Maths Week. That's coming up later this month, and that's the biggest STEM festival in Ireland and the leading maths festival in the world, and that's organised from here. We've Science Week in November happening in all across the Southeast, coordinated as well from here. We'll be running a STEM entrepreneur camp in January, and we have Engineers Week in March, Engineering Your Future then, and SciFest. If you're interested in getting involved in the regional Young Science competition, that will be happening in April and May. All this information will be sent to your schools. I'm going to put this up at the end, remind you at the end. There is more career talks available, including a special careers talk session for girls and featuring young female engineers, and that's on engfest.ie, and you can reach us at calmas@wit.ie. Possibly, if you want to learn more, ask your teacher to get in touch with us, and we'll set up either a Zoom chat with you, or we can organize a real life visit in the new year when things resume back to normal. Okay, so I'm going to pass over now to Stephen. So far we've had, I've tried to give you an overview of what engineering is and where it's come from and the opportunities. And then James and the Red Hat team gave you a very good insight into engineering and the software industry, and some very interesting stories about the paths and journeys of the different panelists. And now we're going to talk about, because there's a lot of focus in this country about academic routes and academic pathways, and another system which is probably the oldest system of education is the apprenticeship of working with people who show you the ropes. This is an area that's really growing, and it's going to grow a lot in the next number of years. Very well developed in places like Germany, and will be more so here. So I'm going to pass you over to Stephen Rooney, and Stephen Rooney is from Engineering the Southeast cluster, representing industry in the cluster, and he's going to talk to you about the apprenticeship routes and opportunities there. Are you right, Stephen?
Yeah, good to go. Share my screen. Now, can you see that?
Yeah, we can see it.
Cool. Okay, so yeah, as I said earlier on, just when I came on for a minute there earlier on, so I'm from the Engineering Southeast cluster. I'm based in the IT in Carlow, and I work with WIT as well. I'll just give a little bit of a background on who we are. I don't want to bore you on it, but it's an Enterprise Ireland initiative in conjunction with the ITs. And look, to sum it up, really, I'm, Owen hinted there, I work with industry really. So I'm kind of almost like an industry liaison there with all the guys in the Southeast region. A cluster itself is really, if you want to define it, it's like a group of companies working together in a certain discipline to collaborate together to make themselves better, to make themselves more, to grow their businesses and to internationalize their businesses. So what we do is we try and use the tools that are there in the ITs and in the other government bodies to help industry really tap into all those resources to try and strengthen their businesses. It's the idea of it is to really be driven by industry. So you're listening to the managers, the owners of companies in the region, and you're trying to find out what kind of pain points they have, I'm trying to help them through it. Like, so when I started in the job a number of months ago, one of the things I would have done was I kind of, you know, went around and visited them or did interviews with them online. And one of the things I discovered is that there's a really, really strong ethos for apprenticeships in the region. We're doing it really, really well. And I think that I just, you know, from talking to them, I think the message wasn't really getting out to the general public that it is an area that we're really, really strong in. And that, you know, I suppose one of the things we wanted to get across as well is that it shouldn't really be considered a sort of a secondary path to an education or to a career, because it just opens so many doors for individuals. Like, and talking to the guys, talking to those industry owners, so many of them would say to me that they're best engineers. The guys they have now as qualified engineers, they started out as apprentices. The apprenticeship model, like, you know, you can stay, you can become an apprentice, you can stay in that, whether it be an electrician or whatever, you can stay in that role for your whole career. But what it does is it opens doors to progress on through other pathways to degree courses and even doctorate levels. So look, it's a super pathway to a career. And I think the fact that you're actually participating, you're doing the work as you're learning as well, is rather than just being bogged down in theory all the time, is really, really good. What we do, we link up with, as I said, IC Carlow and WIT, but we also, you know, and also another big player in it is the ETBs in the region. So the educational and training boards are really important. Some of the key features, just on apprenticeships themselves. So you're looking at something between 2 and 4 years. It's a mix of on the job and off the job training. I like to put this in because I think it's really important to know that from your perspective as a student, or your parents even, like, you know, it's good to know that you're employed under a formal contract of apprenticeship. So you know, there's no ambiguity around it. It's you know, you're signing up to a proper contract. And it's earn as you learn model as well. So it's one of the big advantages over the traditional or the normal college route is that you're getting paid. Now, granted, look, the money isn't spectacular, but it grows with each year that goes past, and it's not bad by the fourth year. But it's really, you know, compare that to actually earning nothing in college, like, you know, and getting yourselves in debt. So it's just another option there, like, you know, and as I said to you, the awards themselves are on a national level. They're between level 5 and level 10 on the national framework. As I say, 10 is up to doctorate level. Some of the key players are the likes of Solus, who would be involved in the traditional sort of trade apprentices over here, your electricians, your plumbers, your carpenters. So there are 27 of those programs. Then you've got the new apprenticeship, or the Apprenticeship Council, who helped develop a bunch of new ones, like there's some brilliant new apprenticeship models like polymer processing, lab analysts, cyber security. There's some fantastic ones out there. Other key players are, as I mentioned, the ETBs and the IoTs, because they actually help deliver the course from the theory side of it, and the employers are absolutely critical to it as well. If you want to learn more about it, I just suggest just go on the Generation Apprenticeship website. It's a brilliant website. And that little image at the bottom just kind of gives a little bit of an idea of how it works, how it pans out. So you start off in the job, then you go off the job into either an ETB or an IoT, and then back into the job again and progress through the different phases. I just looked that slide up quickly just to give a little bit of a snapshot, just to, you know, in the region, you know, what are we looking at in terms of how many people are employed in the different areas. Like, so you can see, like, my focus as engineer in the southeast, my companies that are in my cluster, they're engineering companies, they're manufacturing companies, but there's apprenticeship programs there to suit so many others as well. You know, the retail and hospitality is the biggest sector of employment in the region. And if you look on Generation Apprenticeship, you'll see some of the specific apprenticeship programs that are there for that industry as well. And then on the right hand side, you can see just a little snapshot of some of the courses that are there. Like, but as I say, they're really getting smart about the type of program they're creating. As I say, I go back to the likes of polymer processing. Like, you know, there's tons of jobs out there in that at the moment. It's a real hotspot. Like, so you know, there's loads of really good ones. Just a few kind of key statistics just to mention. If you look at in the last 4 years, we've gone from 27 apprenticeship programs up to 60, so there's much more choice, and that choice is growing all the time. The amount of money invested in it has tripled in the last few years as well. So there's a lot of money going into supplying state-of-the-art equipment in the training facilities to help you guys train up. Another one is, you know, the actual amount of apprenticeships in the system now is up on nearly 20,000. Well, it's over 20,000 now, but by the end of 2020 it was at that, which had doubled in a few years as well. And look, really importantly as well is the amount of women getting into this as well. So I think in the upcoming video there we've got a good example of a girl who's gone into it. But you can see there's been a exponential growth there in the amount of women going into this as well. So that's just a little intro into this video. I mentioned earlier on, I have I robbed this slide from Generation Apprenticeship website. It's basically saying, look, if you're interested, apply. But that big A at the start of it there, one of the guys in our video actually made that, the apprenticeships in one of our companies, CDS in Kilkenny. Super fabrication project that the guys did. That A is actually about 2 meters tall. It's huge. It's massive, and the amount of skills and things that has gone into actually creating that is unbelievable. So look at it, as I said, what I wanted to do was just kind of get that message across to you that there's great opportunities there. I say I have a little bit of a bone to pick with your man Ben from Red Hat earlier. He was saying there he didn't like factory jobs, but I would disagree. I'd say there's great factory jobs out there, and you'll see some of those in this video. I think there's a great range of skills in any of these positions, and I think there's definitely something in it for you guys. So I leave it at that. If the guys want to hit play on the video now, I'll just stop sharing. But as I said, we created this video with local companies. It's got a great mix of apprentices, young people. It's got a great mix of managers and company owners who started out as apprentices as well. So it's brilliant to see that, and there's some good stories there. Like so these guys started off as apprentices. Now they're directors in huge multinational companies. The opportunities are endless in this game. So if you want to play the video there, thank you.
So my own name is Seamus Callan, and I'm Business Development Manager for Clancy Construction. Clancy, I suppose, we're in operation for over 70 years through three generations of Clancy family, and now headed up by John O'Shaughnessy, who's the Managing Director. And you know, we do work nationwide. We've offices in Dublin and in Drangan, and we've large projects off, I suppose, all across Ireland.
My name is Kieran Brennan, the Engineering Manager here at Keenan's, which belong to the Altec Group.
My name is Brian Bible, and I'm the Apprentice Training Manager with OSullivan in Bagnallstown in Carlow.
I'm Martin Stapleton from CDS Metalwork. Our company is involved in metal fabrication.
Hello, my name is Leo Doherty, and I am a Project Director with Toys4 Engineering. We are an electrical and mechanical service provider based in the southeast.
We do an awful lot of work on housing, student accommodation, schools, and yeah, we have very broad portfolio work.
Here we design and build dyed feeders for the agricultural industry.
OSullivan specialise in the production of press tools for the automotive industry to produce panels of cars, wings, doors, bonnets, that sort of thing. OSullivan work directly with a lot of the OEMs, which would be BMW, Mercedes, Volvo, Ford, etc.
We work with designers, interior designers and architects, manufacturing their designs. So they would come to us with a metalwork idea, be it a piece of a handle or a staircase or balconies or whatever, a feature piece, and we would work through it with our design team straight to our fabrication floor, to our finishing team, to our install team, giving them a finished metalwork piece.
Here at Keenan's, we believe in the apprenticeship model. Personally myself, I come from an apprenticeship, trained as a tool maker many years ago, and since progressed on to design engineer.
Since 2004, we have 170 apprentices have came through our system here. So currently we have just under 100 qualified, and there's 50 currently going through their apprenticeship.
So each year, Sure Engineering, we take on about 50 to 100 apprentices, and currently we would have between 300 and 350 apprentices each year, and they're split between electrical, instrumentation, plumbing. And each year then the fourth years qualify out as electricians, and then it's a constant regeneration process where we need first years to come in again and to keep the mix correct on the sites.
So I suppose over the years we probably would have gone through about 30. We take on 1 or 2 every year. So it's very select, very like back to what we do, bespoke. We don't have a huge amount, but we have very high quality. So we look for very high standards, and that's why even from the TY stage, you have to come with your CV. You're coming prepared to work and to learn. You may not stick with it, but both of us have learned from that experience.
Look, I suppose Clancy's are very supportive of apprenticeships, and we've had great success through the years with apprentices that we've brought through I suppose carpenters and blocklayers mainly. You know, up to 2008 there was a lot of support for apprentices, and then I suppose companies went into survival mode really after the crash, and we'd hope to see that it's getting back to a stage now where we can take on more apprentices.
I suppose for any business or any company, particularly in the engineering side of where we're at, to actually hire a guy that will do the job for you is very difficult. Whereas you can take in a guy as an apprentice and mould him and train him in the way you want them, albeit he gets his papers at the end of the day as a toolmaker or an OEM apprentice in this case, but you get to mould the individual to suit the organisation. And in the longer term, they're the individuals that tend to stay with the company. They understand what you're doing, what you're trying to achieve. And I suppose maybe their goals become aligned with the goals of the company over a period of time. So it's beneficial to both parties.
Through training our own apprentices, we gain people who are far more familiar with our quality, our safety, our procedures. Once we train our own apprentices in our own ways, we benefit down the road. We have our own electricians who are familiar with our processes and systems. And those electricians progress through different career paths throughout our business. And from the apprenticeship route, that's where they learn the fundamentals of what we do. And that's where they gain the right balance of education and practical skills on the site.
The reason we have such a strong apprenticeship programme is because these apprentices are going to be the new leaders in AutoLaunch.
My name is Cormac Lawler. I'm coming from a little place, Duckett's Grove, in Carlow itself. I am a third-year apprentice here in AutoLaunch doing toolmaking.
My name is George Healy and I'm from Kilkenny.
My name is Michelle Crotty. I come from Mitchelstown in Cork.
My name is Kieran Down. I'm a second-year OEM apprentice here in Keene and Altec, originally from Ballycallan.
My name is Daniel Toomey. I'm from Tinnahealy, County Wicklow.
So my name is Adrian Lamb. I'm from Mitchelstown, County Cork, and I'm a junior electrical engineer with Sure Engineering.
My name is Conor Maloney. I come from Kilfarney in Ballyfiles, only down the road here in County Kilkenny.
My name is Jake Moore. I come from a place called Lochtagalla in Thurles.
So I came from the apprenticeship from my Leaving Cert, came straight in. I suppose, like a lot of young people, I kind of wanted to do everything and didn't know what to do at the same time. So when I came aware about the apprenticeship, it ticked a lot of boxes, it kind of covered a wide basis, and it's definitely something I was interested in. So I said I'd take the plunge and go for it.
I was obviously doing the Leaving Cert like any other guy. Finished it, didn't really have much to go on, so I went into the first thing that was naturally there to me, which was college. I was always thrown in my face in school, so I picked on anything, and I picked industrial design. I actually went in to do industrial design in Carlow, and I finished the 3 years. I came out with a piece of paper thinking, lovely, I have a great opportunity here for a job. Nothing came around. I decided, I'm going to need something else a bit more, so I went off after getting a level 7 degree. Went in to do the 4th year, realised I was in the wrong place, so I left after that and went to work in a place in Dublin, just a normal office job. Thought there was going to be something there. Job eventually, after about a year and a half, nearly 2 years, became redundant, so I was forced out again. That was a bit of a kick to the teeth, something you definitely don't learn in college, so I had to try and find something that was a bit more secure, and that's when I heard about toolmaking and the apprenticeships.
I was doing social care down in Waterford in college, and as the days went on I didn't like it more and more, so it turned out the apprenticeship came up here and I took it.
I was always interested in working with timber as well when I was in school. Like woodwork and construction and stuff, they were always one of my best subjects like when I was in school, so I kind of just joined the dots then. I kind of headed towards carpentry, then the apprenticeship was there. I took on that job.
I went to an all-girls secondary school and it was very much like college driven. That was the end goal, to get to college. We didn't even, like, apprenticeships weren't mentioned, we didn't know what they were. Electrician was something I had in mind, but it was kind of put to the back of my mind after my guidance counsellor was like, no, like, that's not an option for you. So then I went to college and I kind of left it fairly soon. It just wasn't for me. So I went working for a while and finally decided to go for an apprenticeship, and I was lucky enough to get this and I'm quite enjoying it so far.
I'm from a farm and I was doing that the whole time, and the brothers didn't want to get into it, so we swapped around, and eventually I went to New Zealand for a year, managed 600 cows for 3 months on my own, and came back then, managed a farm here of 250 cows and decided I had enough of it. So I did a week off my own back here then in CDS to see that I enjoy it. I rang me back then to see was I interested in the apprenticeship, and went from there then.
I started in the apprenticeship system because I dropped out of school after the junior cert, and I worked on the buildings for a while, and I just enjoyed working with my hands, but I didn't enjoy driving 3 hours to Dublin or North Dublin every day. It just wasn't for me, so I started looking into apprenticeships then after that. I applied to loads of apprenticeships. There wasn't many willing to take on a school dropout, but luckily with apprenticeships the only thing you need is your junior cert.
So I left school after my leaving cert. I applied for a job as an electrical apprentice. From that then I successfully passed and progressed through my phases to qualify as a tradesperson. From there then I got the graduate programme with Toys4Engineers as a junior electrical engineer to go and do a level 7 electrical engineering degree in Limerick Institute of Technology. And so I'm currently a year in and I have a year left.
I think having the apprenticeship model, it gives great opportunity to the apprentice. They get their trade, but after that there's endless opportunity. You know, we've great tradesmen that have gone on to become site managers. They've gone on to further education and to develop themselves in leadership and management, and have become some of the top MDs in huge companies all over Ireland. So I think you know, getting the trade is very important.
Personally myself, I'm a metal fabricator, so I would have come through the ranks of the apprenticeship system. And I firmly believe in the training and in the structure that's there and in the help that's got. Like an apprenticeship is a passport to the world.
I absolutely loved the trade of tool making, always did. It provided me with an income all through my life. I was never out of work. And I'm just fascinated with making things with my hands and whatever. When I was a younger man, I just loved making things. That's what I wanted to do. I wanted to know how everything worked, how things were made, and I was fortunate enough to get an apprenticeship.
So my own experience in the construction industry, I joined it in 1995 as an electrical apprentice, and in the coming years I qualified as an electrician, and then I progressed into supervision roles, and I've become a foreman, a supervisor, and then I progressed where Toys4Engineers sent me back to University of Limerick, and I qualified in a level 9 management degree there, and I've subsequently progressed to a director within the business. So entering the apprentice route opened the door for me. I learnt the skills, but it allowed me, it was a career path that I followed, and it wasn't just an apprenticeship. And I'm 26 years with Sure now, and it's continually changing my position.
For myself, I trained as a 4-year apprenticeship, then moved on into design, tool making design, or tool design course within the company, and then subsequently went back to college on a full-time basis to Carlow IT and done an honours degree in mechanical engineering, and then further progressed to a master's in mechanical engineering in DIT.
Keenan's is a great place to work up the ladder. It's kind of one of the things I even knew before I even came in here. Kind of a lot of lads around my local area have worked themselves up, like, so that off the bat was a great kind of initiative to come in and do my apprenticeship in here. And then just from the academic side, you can go on and do lots of different other courses and stuff, but especially with the OEM, you're kind of experienced in a lot of different fields, so if you want to branch off for that, it would make the step a lot easier, I think, anyway.
I chose the apprenticeship route because I was always interested in working with my hands, and I always like seeing the practical outcome of fulfilling a task.
And some of the guys were saying you learn as you go. You definitely come in with you can come in with nothing on your back, no experience. You have 4 years to learn it. I had very little, but at the same time I had ambition. I had the goal to go and do all 4 years, which is, I said, right, I've done 3 years in college before. I'm pretty sure I can do this.
I suppose I was interested in electrical because I come from a farm, and we did like small things around the farm, like changing the battery of the tractor, doing fencing, stuff like that. And I just kind of took an interest in it.
See, I'd always be handy with my hands. I'd be always fixing things and whatever, and I was always doing small bits of welding and fixing, well, I suppose butchery at home anyway, but I enjoyed the welding and making a few things, and I said, sure, why not get skilled at it? And it was very, very good skill to get into. Like, you always need a welder, you always need some sort of engineering or something like that to be, as you said, in colleges, they're not doing the same thing. They can only draw it and talk about it, but they can't actually put it together. So that's the way I went with it anyway.
School just wasn't ever my thing. I'm more of a learn by doing. Like, once I'm shown how to do something, I pick it up a lot faster than if I'm sat there and someone's telling you how to do it.
You're learning by doing and sitting with the individual, or not sitting, but working with the individual that pass on the skills. So I suppose it's a slightly different model to the academic model, where you sit in a class and the information is pushed at you. This way you sit and you learn with the guy, or you work with the guy, and you do it right or you do it wrong, but over time you do it the right way, or in our case, the Keenan way.
The apprentice gets paid from day one as well. You know, you go to college, you give 4 years in college, you don't earn any money. You know, you're earning as you're learning, really, with the apprenticeship model, and it can take you anywhere, really. You know, a lot of our qualified apprentices have gone on to set up their own companies.
It's a huge difference to both the parents and the individual doing the apprenticeship. The cost. If you take it, you don't have college fees. The apprentice, I suppose, on average over the 3 years in this case, probably earns 15,000-20,000 maybe on average per year. Whereas if you take it, the student going to college has a negative number for those 3 years, depending on which college he goes to. But by the time you're probably looking at 10, 12, 15,000 on average. So it's a serious difference.
Yeah, you get paid, that's the thing. You get paid to do the apprenticeship, whereas college you have to pay your way through.
You're earning while you're learning. Gives you a bit more financial stability. Like, for example, because being an apprentice here, I was able to buy my first car. It's probably not something I would have been able to do if I was going to college.
It's low to start with. You build up every year.
I took a major hit in the money, but at the end of the day I was just thinking of the bigger picture and got through it. You get used to it, like, and you just get through it. Every year it goes up and it gets easier and easier.
As the wages do go up each year, it's something kind of to work towards. It's kind of nearly the goal to reach it and pass your exams in college, and to get that little bonus for yourself on a personal aspect. So,
being able to have a constant flow of money to live comfortably, we say when working away from home, being able to rent and to live away from home, being independent would be a big advantage to earn as you learn.
It's really hard when you don't have the sports around you to be able to go and take 3 years of not making any money to educate yourself, on top of school fees and transport and everything else. Being able to earn money as you work and educate yourself is really important for me.
I suppose I'm coming from working a full-time job into an apprenticeship, which is actually suiting me fine because I'm able to earn as I learn. So I'm not in college trying to do a part-time job like some of my friends. So I'm able to have my car on the road. I'm able to meet my friends out for coffee. I'm still able to have a social life, but not be restricted.
They can live locally, they can live at home if they want to. They can stick with the GAA club. They can, all clubs survive. When you have apprentices working in your area, everything blossoms, everything survives. Whereas if you go to college, you're gone to Galway or Belfast or Dublin or wherever, you're gone out of your parish, you're gone away, and maybe never to come back.
It is a lot easier to go put yourself on the road, you can do things kind of at whim, like book stuff to go places, buy stuff where maybe some of your friends who are doing in college cannot do. So you have a freedom to do that is a thing. But no, again, like as I said, I'm from Ballinkillen, I'm about 10 minutes over the road. I finish here at 4:30, I'm home by 4:45. I can still do my training, I can still go meet my friends after work or whatever. It's a lot of freedom about the apprenticeship, I feel, yeah.
Well, they come in shy, nervous, into a strange environment. Maybe it's their first work experience, and it's just incredible. Day one, they're just a nervous wreck. They don't know what they're doing. And you see them growing, and they're having a laugh, and they're getting more confidence, getting stronger and stronger. And by Friday, they don't want to go home. You know, it's just fantastic. Oh, we've had a few didn't make it to Tuesday. But generally it's quite good, you know. So, and we've had some females, which is fantastic. The girls are incredible. And to see the transformation in the girl coming from the Monday morning, putting on their safety boots and their safety gear that they'd never wore before, to welding, and it's fantastic. It's fantastic, you know. So.
Getting a better gender balance into the industry is important. It is a very male-dominated industry at the moment, and there's no reason now, with all the new technology and the ways of operations and how well controlled the sites are, that it cannot be a equal balance on a gender front.
The theory also is in it, and the maths and the engineering science and the drawing, etc. That's all in the apprenticeship as well. So the apprentice is getting a really balanced and full academic program from the apprenticeship.
Well, for me, the apprenticeship started off with, I just wanted to do the tool making pretty much. Once I was finished 4 years, I wasn't really sure what I wanted to do. This was in first year, wasn't really sure. So I said, right, once I get tool making done, I'll see where it goes. But now, as I'm in third year now, I've seen aspects of tool making. I've gone into more detail with it, and turns out there's mechanical engineering. You can go on to do a level 8 degree with it, do a bit more intricate work with actual mechanical engineering, or you can actually go with 3D designing, which is what I've done previous in industrial design. I want to learn programs such as SolidWorks, which I will be doing soon in Sligo IT for phase 6, and I'm actually looking to build on that.
Just from what I've done in my 2 years in here, I've been in the drawing office in engineering and design. I've been in maintenance, doing both electrical and mechanical maintenance. I've been in R&D, making jigs, and doing between the step of production and engineering, and just a lot of other stuff like that, welding, anything. I've nearly touched bases on a lot of stuff in my 2 years here already. Like.
You have to do your maths and all that sort of stuff in college for the apprenticeship. You have 6 months at start, and you're doing your drawing, your theory, everything. Like, you have to know the stuff to pass the, like, so I just found it a lot easier, the fact that I needed it for what I was making and what I was doing. It made it a lot more enjoyable to do, I suppose.
Just because you're doing an apprenticeship doesn't mean you're going to miss out in college either. I have gone to Shannon training centres. I've gone to Sligo training centres. As I said, I'm in third year, so I've done my phase 1 in auto launch, phase 2 in Shannon for 20 weeks. That was good. Met a few guys there that were doing other companies, other different styles of tool making. You got to learn that way. Back here for phase 3. Phase 4 was more theory based, got to learn more stuff about tool making, the parts that we're not doing here. So you actually, just because you're in auto launch doing automotive doesn't mean you're not going to learn about the other parts of tool making. Once you go to college, you'll learn about other parts of tool making as well.
Since I came back from college last year, in my first year, my mentor has given me a list of work to be done completed. So I would move every 6 to 8 weeks in through different areas throughout the factory and get a kind of basis for each. Some of these areas include the maintenance department, engineering department, drawing office, some of the production lines and stuff like that. So on that side of my work, I could be doing something different nearly every day if I wanted to. Like, so I think that gives you a lot of basis to improve on your skills and improve on what you learned on in college as well.
I suppose the apprentice at the end of his 3 years, he can actually do, I suppose, real work, for want of a better, on the Keenan machine. He can take it apart, he can do maintenance on it, he can work in any area within the production facility here and have a level of confidence. If we take in a graduate engineer, we have to train him at this point in time after his 3/4 years. We take in graduate engineers for a 2-year training program here.
So what they get is a level 6 craft certificate, which allows them really to go anywhere in the world. They put that ticket in their back pocket, and if they want to travel the world, they're now a skilled craft person. And that allows them, that is a license to travel. Other companies will allow them, any other countries will allow them to come in. For example, Australia, whatever. We've had people that have kind of went all over the world.
We have apprentices all over the world. They're not working for us. They started with us and just branched out to their own thing. And it's fantastic to see. We'd still be in contact, and whenever they're home, they'd call in. It's just fantastic. And there's a whole network of metalworkers that you can pluck ideas from, and you know, it's incredible and very encouraging, you know.
So there's lots of opportunities. It's not just you do your apprenticeship and then you continue working. It's only the first step in your career, really, and you can always fall back on that or move forward, whichever you're interested in doing.
A lot of companies will send, will support you in going back to college then to go into a design route or to go into, engineering or whatever you might want to go into yourself,
If you look at the apprenticeship model and you look at our apprentices and our education system in Ireland, a lot of other countries value our education system, I think, much higher than we do, which is a bit of a shame, because look at all the multinational companies that are in Ireland, and they come here and always they say, look at the skill set they can get, the quality of people.
I think as a whole the construction industry needs to show how attractive a career path in doing an apprenticeship is, because there's you're constantly battling with, I suppose, the perception that you need to go to college first and you need to get your education, but an apprenticeship role, it's a very attractive career path as well. And as I mentioned previously, people that have completed apprenticeships have gone on to become leaders in the industry, and that's what we want to see, and that's what we need to be supporting as well in the industry.
The model works for a lot of other companies, yeah. And there's quite a few companies in this region, in the southeast, that are starting to look ahead now and seeing that there is benefits to it. So I'm sure in the future it'll probably be offered in some of the more local colleges then.
You actually have more than just a piece of paper to say you're now qualified in toolmaking. You actually have 4 years experience, you know what it's about, and if you do happen to go look for another place, you're able to have that experience behind you as well as just a piece of paper. Whereas college, very, very seldomly you'll have the experience. You'll just have the piece of paper, your receipt of where you paid for it. There you go. So apprenticeship was no brainer. I have my experience, I have my piece of paper soon enough. I'll have what I need to push on even further again, like if I wanted to, for anything mechanical engineering to design to anything, I suppose, that's in the same area.
So at the age of 25, I will have a level 7 degree in electrical engineering, as well as being a qualified tradesperson. And in the future, after being granted the opportunity to have the level 7 degree, it's have to give me an incentive to go back and go do my level 8 in the future.
The current challenges with the apprenticeship route at the moment is, I suppose, overcoming the stigma of it in the first place and understanding that it is a career path that can open up many doors. It's a very well-paid industry. People who come through it are on a good wage scale that constantly increases. They're well represented with their unions, etc., etc. So they're never exposed to too much risks or in terms of pay scale. It is a good environment to work in.
If I was giving advice to anyone thinking about going for an apprenticeship, just don't be afraid, but grab the bull by the horns and ride it to death. Don't be afraid of it at all. If it's not for you, you can change your mind and go at a different sector of it.
If you're thinking about doing one, don't hesitate. It opens just as many opportunities as going to college will.
If the apprenticeship system is for you, I think you should go for it.
Being an older status as well, I think I pretty much made the right choice. I have stability. I have a choice of do I stay or do I go as well at the end. Can I build on it? I have so many more choices as well. The apprenticeship doesn't just stop at 4 years. It stops when you decide to.
If you're thinking about an apprenticeship, you should definitely do it, because I let people tell me that I couldn't do it, but here I am now and enjoying it very much.
I would kind of always had in my mind that I was going to college, and I was telling people that, and then when I changed my mind to do an apprenticeship, I kind of got a few looks off people, and Like, I couldn't be happier with what I picked. Like, it's literally the dream job. Like, there's everything going for it. Like, it's very, you have kind of the best of both worlds. You do get your college life, you get your 4 or 5 months away from home and stuff, but you still get to be able to come home, implement your skills, make a few pounds, and it's kind of best of both worlds in my eyes anyway.